This video is going to explore esterification reactions. We're going to start by looking at what is an esterification reaction, and we're going to write the general reaction scheme below. So, an esterification reaction starts with a carboxylic acid. I'm going to represent this as R1, and then my carboxyl group, plus an alcohol. So I'm going to represent my alcohol as R2. I'm going to just write it this way, R2. So on the left, we have a carboxylic acid. And on the right, we have an alcohol. This reaction is going to take place in the presence of an acid catalyst. So we're going to write that over top of our arrow. A handy memory trick is anytime you're reacting an alcohol, you must have an acid present. So what's going to happen in this reaction is we're going to remove water. So we're going to remove a hydroxyl from one and a hydrogen from the other. You won't need to know which one comes from where, just that water is removed. These reactions are also called condensation reactions because condensation is the removal of water from air. So condensation, removal of water from between two molecules. This is going to give us our product. So we're going to have R1, and then we'll have our double bond to oxygen. We'll still have our O, and then bonded to R2. And so this is an ester, and it contains our ester linkage. So this section of the molecule here, this is our ester link, and our inorganic byproduct here is liquid water. So the first example that we're going to look at is the reaction of propanol with ethanoic acid. So this, propan-1-ol, we're going to draw in blue, and ethanoic acid we're going to draw in red so that we can see where each part comes from. So we'll start by drawing our ethanoic acid. So ethanoic acid is 2 carbons, including the carbon of our carbonyl. And we're going to add our propanol. Now when you're drawing our esterification reactions, the easiest way to draw these reactions is to line up the 2 hydroxyl groups. So propan-1-ol will have 3 carbons with a carbon on the first, or alcohol on the first carbon. The reason we want to line up these 2 hydroxyls is that it's easy to circle or to see the 2 parts of water that you're going to be removing, so a hydrogen from one, a hydroxyl from the other. And you can then visualize more easily kind of smushing those 2 molecules together. So we're going to do this in the presence of an acid catalyst, and our product is going to be, so our ethanoic acid component, and then the alcohol component. And then our inorganic byproduct will be water. So I'm just going to write that as HOH. And we can name these parts. So we have ethanoic acid, propan-1-ol, and then our product is propyl, that's our alcohol component, and then ethanoate, that's our acid component, and we change the ending of the name to OH. Our next example is slightly more complicated, so we're going to do the same steps again. So once again, our alcohol we're going to show in one color, and our acid will show in another. So we'll start by drawing propanoic acid. Propanoic acid has 3 carbons, including the carbonyl. So that's 3 carbons. We draw our double bond to oxygen, and then our OH group. And once again, we're going to line up the 2 hydroxyl groups. So now we're going to draw butane 2-ol. So I have my OH group, and then it's the second carbon on a 4-carbon chain. So 1, 2, 3, 4. So we have 1 carbon up here. This is carbon 2, carbon 3, and carbon 4. As this is a condensation reaction, we're going to be removing water from between these 2 molecules. So this is going to be removed, and we're going to react this in the presence of an acid catalyst. So our product will be our 3-carbon component from the acid and our 4-carbon component from our alcohol. So our reactants were propanoic acid, butane 2-ol, and our product is 1-methyl propyl propanoate. So if we look, this is carbon 1 in our ester, 2 and 3. So what was part of the original branch on the alcohol is now a branch off of the parent chain in our ester. Our last example that we're going to look at is working backwards. So we're going to start with our ester, and we're going to work backwards to see which 2 reactants would have formed it. So we are going to have 1-methyl cyclohexyl. So cyclohexyl is our parent. And at carbon 1, we have our oxygen bond as well as a methyl. That's going to be bonded to our ester link. And then we have propyl hexanoate. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. And on carbon 3, so carbon 1, carbon 2, carbon 3, there's going to be a propyl. 1, 2, 3 carbons. So that is our ester. This is 1-methyl cyclohexyl, 2-propyl hexanoate. So in order to go backwards, we're going to break this ester link here. And we're going to do that by adding water. So when we add water, our alcohol will go back to being an alcohol, and our acid, so we'll put an OH on here, will go back to being an acid. So those are our 2 components, and we can name them. So our alcohol component is 1-methyl cyclohexanol, and our acid component is 3-propyl hexanoic acid.